Yeah, hello students. Here I'm working on problem number 2.8 practice problem. So this is from practice problem homework 2.8, and this is on graph on inverse functions. So in the class we did 1 through 8. So I did 8 practice problems. So let's do practice problem 9. So this video will have only practice problem 9. So the question here is find the inverse of the function. So you're given a function 7 minus x cubed. So how do you figure out uh, this 7 minus 9x cubed function? So all you do is the first step, instead of f of x, I'll try to use y. Output as y. So 7 minus 9x, and then you interchange, replace x by y and y by x. So this becomes x equals 7 minus 9y. And then you solve for y now. So how do we solve for y? So subtract 7 both sides. This will be x minus 7 equals minus 9y, and then divide by minus 9. So this goes away and you get y equals x minus 7 over minus 9. This could be, because there's a minus, it's better to swap this x minus 7 to 7 minus x and just write a 9. And now we replace this by a new function. And the new function we can use is f inverse of x and 7 minus x, and we're done. But you may write this as also as 7 over 9 minus x over 9, or you could also write minus x over 9 plus 7 over 9 means the same thing. So that takes care of inverse function, and hope that helps. Just wanted to know this function is a 1 1. So if this function is a 1 1, so naturally it has a inverse. So this is the inverse. Let's go to problem number 10. So question number 10 is f of x is given a rational function. Again, replace this by y. So y equals x over x plus 9, and then replace x by y, and then y by x. So this will be x, x equals y divided by y plus 9. Then multiply both sides by this y plus 9. You cannot, let's get away with the fraction. So y plus 9 this side and y plus 9. So that way we can cross out y plus 9, and you use the right distributive property, which is xy plus 9x equals y. And then we need to get everything y is on one side. So this y, which you see, it has to be taken to the left side. So subtract y. So when you subtract y, you get xy minus y plus 9x equals 0. And then subtract 9x on both sides. So this will give you, and then at the same time, you can see there's a y which is multiplies x here, and also y multiplies to maybe 1. Yes, that's 1. So we can pull out y, and what stays is x minus 1. This crosses out and you get minus 9x, and then divide by x minus 1 both sides. And that way we get this 2 will cross out and get y equals minus 9 over x minus 1. And because there's a minus, of course this is correct, but you can also write it as 9 minus 1 minus x, same thing. And the final answer that you get right is f of inverse. That means f inverse is 9 minus 1 minus x. That's it. You're done. Let's go to problem number. So question number 11. This is 11 practice problem. So again, replace f of x by y. So y equals 9x plus 7, and then divided by x minus 3. So replace x and y. So x is replaced by y. So this will be x equals 9 y, x will be y, and then plus 7 divided by y minus 3. So we can use also directly here uh, cross product also. Instead of multiplying y minus 3 both sides, just multiply x in that one. And the other one will be this multiply. So when you have equal, when you multiply 1 on the right side, 9y plus 7, that 9y plus 7 stays the same. And the left side will be multiplying the x, which you see this x is multiplied to y, which will be xy. And the same x is multiplied to minus 3 will be minus 3x. Okay, now we need to solve for bring the y's on the left. So subtract 9y this side and subtract 9y this side. And at the same time, you get away with the minus 3x, which is we don't need x. X has to be on the right side. So we do this two steps. Two steps can be done right there. So this will be xy minus 9y equals this crosses out, and you get 7 plus 3x. Then you can see that the y, which is multiplied to both x and 9. So we can write it y, undo distributive property, and write this is x minus 9, 7 plus 3x, and now you divide both sides by x minus 9, x minus 9, and you get y, this crosses out, and you get the same thing, 7 plus 3x over x minus 9. And then this y is nothing but f inverse of x equals 7 plus 3x and x minus 9. That's the problem. That's the answer for the inverse function of f. Let's go to 12. So problem number 12 is check whether the function has an inverse. Remember, the inverse function is possible provided either each of the from the domain, each of the x value should have only one image here. You can't have two of the x's going this way. That's so then when you interchange this, it should not be one going to two, then it's not going to be a function. Or it's like that's what we have to check. Does the two inputs give you one output? So what we'll do here is this is a piecewise function. So first let's take what is this function means to us. So x plus 3. So what is f of x plus 3? And this is same as writing x plus 3. So this is y equals x plus 3, right? So that means this is y equals 1 times x plus 3. So this is the slope m, and that's the y-intercept. So the graph will look like this. So the graph will be is 3. So 1, 2, 3. So that's where it starts at 0. Because it is strictly less than this, there will be a hole here. And the slope is 1. Now slope is 1 means 1 over 1. Or I can write minus 1 over minus 1. It means you go 1 down, and 1 left. So you go 1 down and you go 1 left. So this way. And you go 1 down and 1 left. So you have a line like this. See? That's the So this is the line for the first one. What about the second one? Look at this 5 minus x. So if I write y equals 5 minus x, then this is same as writing y equals minus x plus 5. This is same thing, minus 1 times x plus 5. So the slope is minus 1. And that's where you start the 5. So where is the 5? You draw the line up all the way. So this is 1, 2, and 3, then 4, and this is 5. So that 5 here x can be equal to 0. So when x equals to 0, the number is 5. So you start at 5 So this is where this is included, right? This is included. And then again, the slope is minus 1. What this means is minus 1 means minus 1 over 1. Means you go 1 right. So if you go 1 right, so you go 1 down. So that means you go 1 down, you go 1 right, like this. You go 1 down and 1 right. So this is the line. And clearly you can see that this is not, if you see this function, you can draw a horizontal line. If I draw a horizontal line, clearly shows that it has two values. That means two of the axes here, two of the axes I can call x1 and x2. So these are different. Remember, x1 is not equal to x2, but but f of x1, the output, they become equal to x. So the two outputs for, let's say this is 2, let's say this one, they have the same input. So that's like many one. And many, if a function is many one, then you cannot have inverse. So inverse is not possible. So you should know why the inverse is not possible, because this is not a one one. So let me clean this and write down. This is not one one. That's it. You're done. So I hope that clarifies problem number 12. Let's see problem number 13. So 13 is find the inverse, and this time they have a radical. Remember, you just put this as y, 7 plus square root of 4 plus x. So all you do first is replace y by x and replace x by y, and then solve for y. So here what I'm going to do is this will be subtract 7 both sides. So if you subtract 7 both sides, you get x minus 7 equals, this crosses out, and you get square root of 4 plus y. Now square both sides. So that means if you square, so this will be x minus 7, the whole square equals, and the right side will be 4 plus y, and then subtract 4 from both the sides. And this y, I'm going to write here y. At the same time, I'm going to write shortcut and say, hey, that's f inverse of x, because y is, now it's like, okay, let me write the whole step then. This goes away and you get y equals x minus 7 the whole square minus 4. And so we have a new function. You can call it like a gx also, or you can call it tx also. But because because the original function was f, so we use f raised to minus 1. That's all it is. So f raised to minus of x is x minus 7 the whole square minus 4. And you also need to see what is the domain and the range. Now, so for this, what's the domain of this? So we need to figure out that out. And what is the range for this? Now, if you see the original function, x is given, the original function is given, this function which is right here is, if you see over here, okay, so let's see, so original function that you see, this is the original function. And what is the domain of the original function? Clearly, you can see you can't have a radical to be negative. So this has to be x plus 4. This whole thing has to be greater than equal to 0. And if you subtract 4 from both sides, you get x is greater than negative 4. So all it means it has to be negative 4 and all the way to plus anything above negative 4. So this is the domain. And what is the range of this function? So if you see, the lowest is good when it is negative 4, this whole thing will become 0. This will be 0. So 7 becomes the lowest. And you can clearly see the graph also. The one thing is visuals are very clear how the graph goes to the lowest is the 7. So, and then it goes up. The output becomes very large. So therefore, the range is starts from 7 and then goes all the way to plus infinity. Now remember for the for the inverse, now this thing is only for the function, the original function, but for the inverse function, it swaps. That means the range becomes the domain. So here, domain and the range, they interchange. That means this 7 to infinity become here 7 to infinity. And the range here is -4 plus infinity. So this is for the function, this one, the one that we got this one, see? So x minus 7. So even though x minus 7 plus 4, how the graph will look like. And you can see it is a parabola. It is a parabola with the vertex. If you see the opposite, if you compare this with the vertex form x minus h the whole square plus k, and you see the vertex is hk. So the h is, if you see, this is -7, which is therefore it becomes 7. K is the -4 as it is, so this becomes the vertex. So I don't have enough room, so I would just write here vertex is 7 minus 4. That means I have to start the graphing from let's say the vertex is mm, 7 minus 4. That means 1, 2, 3, 4, 5, 6, 7, and 1, 2, 3, and 4. So this is the vertex. And the parabola is upward. You can clearly see it's a parabola which concaves up or upward. So something like this. The question is, do we have to take both? Is this going to be the graph, or is it going to be only the left one to the left of this? Is this the graph? Now you can see clearly what is the inverse function is always reflects over the over the y equals this. So if I do draw a dotted line, it has to reflect over this line. See, like this. So naturally I can't take because the domain of the inverse function is, look, if you see at the bottom, it starts from 7. So you can't take to the left of 7. So if this is 7, it has to be only from right, this side. So the graph is going to be from this side, like this one, and not this part. So let me do it one more time. So the graph has to be so the graph's this way. This is how the graph. So you don't see that. So if you see the whole thing, and you can clearly see beautiful graph. The first one is this goes this way, and this graph goes this way. And of course, it's not perfect, but just to show it's a reflection. It's a reflection over the line x equals. So what is a good thing is even though you get a parabola equation as an equation of a parabola here, but it's not a whole parabola, it's only the part of it, the right side only. That's what is important. And one thing is good, they gave you already here, see, they did give us the domain of the inverse function is already given to you this one. It means it's saying from 7 in plus to infinity. They should not have even given this. You are supposed to figure out what is the domain and the range. So anyway, I hope I made very clear. One thing is, what is the inverse function, and then also how do you find the domain and the range? So first you find this domain and then flip it. That's it. You're done. And the visuals are clearly, you can graph also the square root function and then the inverse function, which is a parabola, goes like that, and it takes care. So problem number 14 is, so they did give us a square root function. We know the parent function of the square root function is this is what, but because there is a +4, so you can see the graph shift 4 units to the left because of this +4. So you do the opposite of the number inside. So that means this graph shift somewhere here or something like that. So let me do it nicely. So they're asking you what is the graph will look like. So if I draw this, so the main one, the one that is given you, the one that square root is plus here. So the good thing is it's plus, be careful. So that means it moves 1, 2, 3, and 4. So that's -4. And this is it. So there's nothing outside the function. So this is the graph of the square root function. Now, if just imagine if this was like this x plus 4, then it will be going downward. So this will be this way. So negative in down. Right now, and the domain. So the domain of this function is so d is, and you can clearly see the lowest it goes is 0. That's the 0, right? The the domain. Okay, sorry. The domain is -4. So the domain is -4 plus infinity, and the range is the lowest is goes to here 0, right? So this is the range. So this is begins at 0, because when you put x equals -4 here, it becomes -4 plus +4 is 0. So 0 is the lowest it can go. So the range is 0 to, and it goes up all the way like this. So sorry. So hope that clarifies. So plus infinity here. So when you want to find the new function, this is the one that we did is for f, and if I want to find for the f inverse, so for the f inverse, you replace this, so it has to start from 0 to plus infinity, and this goes, and this one range will become plus infinity. So where is the graph then? So how do we sketch it? So we already did, this is for f. Now I'm going to draw the number line, dotted line, y equal. So we need to reflect this whole thing has to be reflected like. Now, then the curve starts at -4. So, sorry, the 0, it starts at 0. So this is where it starts. Okay. And we can use our knowledge also. This is -4 and 0. So this number reflects over this line. And you just have to flip this, swap this. It becomes 0 for -4. This becomes -4. This point goes like this. So, and you can say in order to reflect, so this has to go something like this, see? And you are actually done. That's how the graph will look like. That's not good. Maybe this is how the graph will be like. See? Now, how do we find the actual expression for this? So for that, you have to do some work. So they give us f is square root of x plus 4. So you just have to write this as y equals square root of x plus 4. Then switch x and y's. So this becomes x equals square root of y plus 4. Then you square both sides. What is that square both sides means? You put square this side, put a square this side. So this is x squared equals y plus 4. And then subtract 4. And you can clearly see this goes away. You can write y equals, this whole thing is x squared minus 4. That's the parabola. So basically, this is actual parabola is is if this is the original, the same thing goes down like this to 4. So that's the what. But we can have only to the right side. We can't have the left side. So I'll have to take the left side and only graph the right side, this side. See? So this has to be, so that's what I'm trying to say. Only the right side. This one only. I hope that, and then of course this is f inverse of x equals x squared minus 4, and it clarifies you have sketched, this is the original graph, this is the inverse function, the domain here is -4 to plus infinity, the range is 0 to, but for the inverse function, it starts from this side. So this one is the domain, and the range begins from -4 here, and it goes up. So I hope that makes it clear. So let's go to the next question. Remember, there will be A, B, C. So you're supposed to find graph it for the original function. Then the B is, can you graph by looking at this, how this will look like? And the last one is what you have to figure out this part. And I hope that takes care. Question number 15 here, 15. Is for his services, a private investigator requires 650 retainer fee. So this is fixed money. So in advance, so every private investigator charges. This is his fixed amount. And when I talk about fixed means this is the y-intercept in the equation y equals mx plus b and plus 75 per hour. So this is the rate per hour. So every 1 hour you are spending $75. So that's the slope, the rate of spending. So this becomes the function. The new function here is given to you. This function is nothing but what does x represent? It represents the number of hours the investigator spends working. So x represents the number of hours spent, hours the investigator spends. So that means if x is the number of hours spent, so multiply by the every hour is 75. So you have to multiply 75. That's the slope, and the retainer fee is 650. So this is how I get. So that becomes the main function f of x. So f of x is 75x plus 650. So this is the original function. Now you have to find the inverse function, and also what does it mean to you? Like that's most important is you have to they did give you a the first part is you create model the real relevance in real life problem into a linear equation function, and then you try to figure out the inverse. Inverse is because here the fee the so it's like the domain is the x hours the hours spent the time. The domain is the time, and this is the cost, how much you pay. So now we want to know the cost. The cost. So we want to go back and say, okay, if it is cost so much, then how many hours can be spent? So this is how many hours the investigator can spend investigating. Okay. So let's write down this is f of x equals is 75x plus 650. So instead of f of x, I'll take this f of x and put y. Remember, it's the same thing like that we did before. And then replace x and y. So if you replace x and y, get x equals 75y plus 650. That means now you subtract 650, you are solving for y. So 75y will remain, this goes away, and this is x minus 650, and then divide by, I think I forgot that 75. So 75 divided by 75 and you're done. So your new function will be y equals, so y is x. So you have to subtract 650 and divide by 75. So this answer becomes x minus, so that's the f inverse, the new function which represents the number of hours that can be spent investigating for the money that you spend or x number of money that you spend 75. Now by looking at this, this is x now, and the numerator has to be positive, right? You can't have a negative x cost. So there has to be some money here. So that means x has to be greater than 650 to have some time to spend on investigating. So let's see. The another question they're asking is, what does this basically mean? So what understanding this is more important because everybody does this, but did you understand this? This basically means this function represents the the number of, so this is the number of hours, so number of hours the investigator, so the number of hours the investigator spends for, so number of hours the investigator spend investigating for x number of dollars, or x amount of dollars spent. So that's what you're trying to figure out in the next question. So the let me write it. So the function was x minus 650 divided by 75, and the question is asked, what represents this. So I wanted to check this out. Clearly says the same thing what I said. So this represents the number of hours of investigation the investigator spends on a case. So this is he is on a case, but he's so that number of hours is the domain, and sorry, this becomes the range. X is the number of dollars spent. So this side, so this is the dollars that you spend, and how many hours you the investigator gets to investigate. That's the range part. I hope I'm very clear about this. So this rather clearly says that whatever the function means. Now another question is suppose he's spending X dollars. So you have 2,150. Means you just have to put 2150 and 2150 and you subtract and you get the answer and you will see there will be 20 hours. So this is the unit. So for 20 hours investigation, you need 2150. So if you have 2150 money, if you have money this much is the hours that you can the attorney or the representative can have to spend money on investigation. So hope that helps, and I hope you understand. Now look at the question here. Yeah, this is question number 16. There's one problem given to you. F of x is x minus 3 whole. So by just looking at you know the what is the graph, right? So this is x minus 3 the whole square. It is the original graph of the parent function. That means this is the graph, but this graph has shifted 3 units to the right because there's a minus 3. So this graph is 1, 2, 3. So this is the graph. But then if you see if you consider this graph, this graph will not have this function. Let's say if I have x minus 3 the whole square, this will not have inverse. So why it will not have inverse is because if you draw the horizontal line dash and you see it cuts two places. So for two inputs, the output is the same. You can see that part. So so something has to be done. So what it is restrict the domain of the original function. So even though the original function is now remember this is the graph, right? So what we do here is the domain is right here. So you can see it. Of course, domain can be anything. It's this side and this side. Domain is negative infinity to plus infinity, but you restrict. So they restrict the domain to this one, x greater than equal to. So I'll cut off the left portion is cut off, and only so that means the graph here is only the part of the. So if it is 1, 2, and 3, so this is the graph of the not the whole parabola, but only this much. So this is the graph which is at 3. Now the question is, what is the inverse, right? So the inverse is by if you look at it, this is 3 comma 0, so it has to be 0 3. So if it is 0 here and the 1, so the 0 3 will be up 1, 2, and 3. So this will be 0 3. So it has to be like this. But then of course by using our common sense, if you draw a dotted line is y equals x, and you just have to reflect the whole graph. So that means whatever the graph that we have drawn on the other side, we'll have to draw another graph which will be something like this, see? Like this. And it is a square root, and let's see why. So they gave us this. So let's solve this for what. So the first thing is f of x is given. So this fx I replace it by y. All you do is replace x and y's and put it this way. So so they say, let me write that. And this whole thing becomes x equals y minus 3 the whole square. And now solve for x. So put a square root both the sides. So square root both sides. Okay. So when you take square root, it is plus minus square root of x uh, equals y minus 3. Now the question is, okay, uh, should I take minus or should I take plus? That's the question here, right? So this is y minus 3, and then you have to add also. So if I add, so this becomes y is, this 3 goes away, and uh, you get plus minus square root of x and plus 3. Now the question is, how do we know it is plus or minus? Now look at this. The original function, the domain is restricted. So the domain and the range. So the domain is 3 to infinity, and the range is, and the range. Now, how do we know range? Of course, here you can, by just looking at it, you know, it means the lowest it can go is when x equals 3. 3 minus 3 is 0. So the range becomes 0 to plus infinity. So that means now you want to find the, this is for f, right? This is for f of x. Okay. Now, if it is inverse, all I do is you swap this. So the domain here will be is 0 to plus infinity, and the other one is plus 3 to plus infinity. That means when you, so that means x has to be greater than 0. So x has to be greater than 0. X is either 0 or positive. That means the graph has to be to the right side. So this graph, so this is the square root positive, has to be, it has to be only this side 0, 0 from here and all the way. That's what it means. So that's why we have to take this off. But still, both the equation have the same domain as positive. But how do we know which one is the right one? If you see this, let me clean this off, and you see this part. So how do we know which is the right one? So I'm going to write both of them plus square root of x plus 3, and the other one is y equals minus square root of x plus 3. Now remember, uh, when you graph, when you graph, uh, so all you do is if you check this, this graph will be, this graph is a square root of graph which shifts 3 up. So if this is the original graph, so this graph shifts 1, 2, and 3. So this has to be the shift. But if I want to graph this one, there's a minus x. So if this is the original one, this graph is first reflect over the x-axis like this, and then it moves 3 units up. So it will look like this. So when you do that, this graph, is it really, does the input give you the output? So if you see, if I try to draw this graph this way, if I try to draw like this, but this graph will not be, it's not a reflection of the original graph. And that's why we cannot take the negative one. So this question, little trickier, but remember, this is the only one that is satisfied. In other words, this is, sorry, so this is the right answer, and this cannot be the answer. That's all I wanted to show. Hope I made sense. And so it looks like only by graphing we know the reflection over the y. This is the reflection over the line y equals x does take place. That's the important part there. Or any point here, let's see if I have a point, let's see, if I take any one point, maybe 4 here, let's see 4. So, and the main function is this one, or maybe 5. Let's take 5 here. So let's see, this is 5. The original function is f of 5 is 5 minus 3, the whole square is 2 square, and you get 4. That means 5 goes to 4. Now, if you try to put this, so the inverse function should have 4, 5. So that means you plug in 4 here and check whether you get 5. Or you put 5, put here, do you get 5? So if you put the here, it is root of 4 plus 3, and that is, if you work, this will be minus 2. 2 plus 3 is 1, and see, this is not correct. So you don't get 5, but if you put here, it's like, I think you can always put a point. If you don't know what is a graph, I would just put a point and see whether that works or not. So now they tricked us here. They said the function, in this 17, problem number 17, there's x less than equal to 0, right? That means there is this function is f of x. It's just a graph transposition of the original function parabola like this. So which has which has shifted 8 units to the down. So this is how it is. But then they said only to take, so that you have this, so let's take this is the x-axis, this is the y-axis, and the 8 is, so this is, it has to be negative. So it means it goes down. So maybe this is 2, 4, 6, and 8. So this is the graph. And then let's take that is 8. This is a negative 8. So that's negative 8. And the graph. So the question is, should we, because it says x has to be less than equal to 0, it has to be only the this side. So that means your graph will be something like this. See, this is the shape of the graph. Now, if this is the point, the other point has to be, so this is minus 8 comma 0. The other point has to be 0 comma 8. So where is 0, 8? So sorry, 0 comma minus 8. So 0 comma minus 8 will be, I made a slight mistake here. Yeah. So sorry, this was 0 comma minus 8. I was making a mistake. Now I have to swap this. So when you swap this, the inverse function will has to have minus 8. So where is minus 8? So maybe here. So this is going to be minus 8. So that point will be minus 8 comma 0. Now remember, the question is but we can easily graph this. So the graph will be, it starts from here and it has to reflect over the line. So it has to reflect over this line. Okay, y equals x. So the only way it is possible, you can do your thinking and say, okay, so this was, so the by just looking at it, you know, it has to be, the question is, does it go up or does it go down? So should I graph this way? Will that shows reflection well? Or will this, or will this show well? Say? And you can see this one looks better, and clearly it is a reflection of the point. But then how do we check this out? Let's see. So this f of x, I'll put it like a y is x squared minus n, and interchange x and y, which is y squared. And now we add plus 8 both sides. So that will be, this crosses out, you get x plus 8 is y square. And you can see put a square root both sides. So when you do that, put a square root, that is x plus 8, and the right side is y, but this is plus or minus. So the question is, which one is the right one? And you can see because of the graph that you see, I will knock off the plus sign and become minus. In other words, if you see in the original function, what's the domain? Let's say this part they did tell us what is the domain here. It means from minus infinity to 0 is the domain, and the range is, and you can see when you put a 0, if you put a 0 here, is minus 8. So the pink color, the range was from minus 8 all the way to plus infinity. So this is the domain for the original function. And this is the range for the original function. And then all you do is, this is for f. So f inverse is, you swap this. So this becomes minus 8 plus infinity. And this goes this side. So, sorry, minus infinity all the way to 8. Sorry. So, minus 8, minus 8. Wait, did I make a mistake? So I think I messed up here again. So this I have to, this should be 0 here. Let me put a black color. So this is 0 because the original function is, the domain is, so the domain here is, this will be, this I have to change. So this will be from minus infinity. So this goes right here. So minus infinity till 0. So this can be taken here. So this part is 0 can be taken. So this is the mistake I did. So this is correct. Uh, so this domain becomes the range of the, so this domain becomes the range here. So minus infinity to 0. That's because this graph, which you see the square root function is like this. This goes all the way down. Down means this takes very large negative values. So almost they become minus infinity, and that's why you see this range and this graph increases. See, it goes up until here till 0. So till 0. So that's the range part. This is what I'm talking about. Is from minus infinity until 0. Hope this clarifies the entire question. So that's why we have to take minus. So this is minus. So y is minus square root of x plus y. This graph below the x-axis, reflection over the x-axis. The last question is problem number 18 is you are given f of x. So let's see. All you do is, what does this mean is find the inverse. So put it y equals x over 7 over 9. Replace x and y. So x becomes y 7 over 9. Which is same as y. I write this way, and then it is x. And now you times 9/7 both sides. So so you take the, like how we have, suppose you have y 1/3 is x. So all do is you cube both sides, right? And that's why I say y equals x. Same thing here we do. Uh, the both side, this side and this side here, you do the 9 over 7 both sides. So 9 over 7, and here also 9 over 7. So you get y is x 9 over 7. And you can see the 7, which is a down number, is odd. So basically what will happen is this will be, for this function, the domain could be anything, but the domain of this is the range f here. So what's going on right now here, this function, the domain is all. You can plot, because of this 9, which is odd, you can say the domain is minus infinity plus infinity, and the range is doesn't have nothing. So this also is minus infinity plus infinity. So therefore, when you take the new function f inverse, and this and this interchanges. So for this function, which is x 9 over 7, so we say we just have to swap this domain and the range. So this become minus infinity plus infinity, and this also become minus infinity plus infinity. But the question is, even we need to know what does this graph means. So basically, it is like 1 point something like this. So the graph is the main, the main one, 7 over 9 is the fraction. So it is 7 over 9 is 9 square root of x raised to 7. So this part, it's something like this. So basically, it is something like this. And the other graph will be something like this. But they have to exactly reflect over the line y equals to x. So let me check the graph. If you see, they gave you option, the bottom two, if you see this one and this one, this you can see the dotted line is not y equals x. So this is not going through the original. Even this one dotted line is not through the original, which is y equals x. So this cannot be answered. The only option is the top two. And the question is, which is the right one? And you can see this one is clearly shows that the graph is a reflection of the first one. The black one is the reflection of, uh, the blue is the reflection of the black one. So even what I did was wrong there, see, because this is very tricky here. So, so this graph, so because the original function was y, let me explain this very nice, the tricky part. This was 7 over 9, and you can clearly 7 over 9 is is less than 0. So it's less than 1. So if it is less than 1, the graph has to be something like this. This has to be the graph. Because if it is 9 over 7, what is the meaning of 9 over 7? X raised to 9 over 7. This is like x raised to 1 point something. So whenever this part is, so this part is less than 1, this is less than 1, so the graph will go something like this. Okay? But if it is this part is greater than 1, then that graph will be this way. Okay? This way. So just wanted to clear that part. I hope I'm making sense here. So by just now, by just looking at it, and you can see this graph, the F graph. So this is the F graph, which looks this way. This is the correct one. And the blue one is the reflection of the blue is the reflection of the black. So the black is, so the question is, why is this correct answer? Just want to make sure we get it 100%. So the black one is, this is the graph of the black graph, which goes this way, which is f of x equals x raised to 7 over 9. And I said this part is smaller number, and maybe x is 0 point something, 9 8 72, 9 sevens are 63, so something like blah blah blah. So that's how the shape of this graph will look like. And you can see this graph by just looking at it. The domain is minus infinity plus infinity, and the range is minus infinity plus infinity. And then you swap it, this new function f inverse, the blue one now, is x raised to 9 over 7. And this 9 over 7 is greater than 1. That means it is 1 point, I think it is 1.2 and blah, 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 blah. So naturally it has to be graph. This is the graph of that. Because if you see x, if it is x raised to 2, then it is like this. If it is x raised to 3, this is going to be this way. This will be x raised to 3. And then if it is x raised to 4, this will be something like this. If it is x raised to 5, then it goes this way, becomes skinny like this. What is important is this number is 1.2. So this will be between 2 and 3. So something like this. And I hope I'm making little sense there. Okay, with this I end all the problems. So this is homework practice problem 2.8. Problem from, I think I did from 8 to all the way to 19. I forgot which one. And the rest you guys do. All the best. Mhm.